we'll have a look at the quotient rule then. Quotient rule is in your log tables here. And if you see something over something, you can use the quotient rule. So if, you get y equals something over something, you're allowed to use the quotient rule. So, even over here, you can kind of see, nothing's really going to help me to do with something over something. Yeah, okay, if you look here, you do have the cos of something over something, cos inverse. But if you just have, a function with something over something, this isn't going to help. The product rule isn't going to help, so the quotient rule is next. So that's the order in which I do things in. We check here. If it's exactly like this, then that's nice. If it's not, we see if we can use the product rule, see if it looks like this. If it doesn't look like this, or I can't simplify it and make it look like that, then I might try and use the quotient rule. So that's what I'm going to look at now. You could get this question, and again, there's two ways to do it. Like the one that we did in the last video, if you get a function, you could rewrite it, just means maybe simplify it. Simplify and then differentiate. Or don't bother simplifying, just try and use the log tables, whatever method, to differentiate. So I'm going to show you that this can be done two ways again. Now, not everything can be done two ways. Like some of them you'll just be stuck. There'll only be, maybe you can only use the quotient rule. But I want to show you that a lot of the time, you do have options. Just take your time and make sure that you're able to use your log tables correctly. So I'm going to go for the first method, which is I'm going to check if I can simplify. So, I have a fraction. How do you simplify? Well, how did you ever simplify any fraction? What's 6 made up of? The factors 2 times 3. What's 10 made up of? The factors of 2 times 5. And I can simplify. So in order to simplify a fraction, I'm going to factorize the top, factorize the bottom, and see if they have any factor in common. So let's just check that out. This is an algebraic fraction. That doesn't mean that it doesn't abide by these rules. Of course it does. If you want to simplify any fraction, you factorize the top, factorize the bottom, and see if you can simplify. So this is x squared minus 9. You have 6 methods of factorizing. Common factor? No. Is it grouping? No. Is it a trinomial? No. Is it the difference 2 squares? Yes, I can use the difference 2 squares here. So I'm going to write it as x squared minus 3 squared, which means 2 factors are x minus 3 and x plus 3. Here's a trinomial. Easily should be able to factorize those. When you do factorize, you end up with that. The factors in common. So when I simplify this, I end up with that. So step 1, or option 1, I guess, is you could simplify, and now I'm going to differentiate. So if I try to differentiate this, and I look at, it still looks like this. The top I'm calling u and the bottom I'm calling v. So u is x minus 3 and v is an x plus 1. And if I look at my formula here, do I want dy dx? So, y equals in terms of x. So y equals in terms of x. Do I want dy dx? What does that mean? Do I want to differentiate the function called y that's written in the variable x? Yes, I do. Well, they tell me if you want dy dx, and this is all from the log tables, v times du dx minus u times dv dx, all over v squared. So v, x plus 1, times du dx. Well, what does that mean? It means differentiate the function that's called u and it has the variable x in it. So there's the function called u and it has the variable x in it. Differentiate that. Well, it's just the basic, bring the power in front, subtract 1 from the original power. Du dx When you differentiate all that, you end up at 1. So times a 1 minus u x minus 3. Now be very careful here, that minus is going to impact everything after it, times dv dx. So differentiate the function called v that has the variable x in it. There's the function v with the variable x in it. So if I differentiate that, dv dx, again, bring the power in front, subtract 1 from the original power, I end up with a 1. So you can put the 1 here, you know, or you can actually put it in front here, whichever. Just as long as you remember, be careful with that minus, it'll impact everything after. So I'm actually just going to put the 1 in front because it reminds me to use that minus. All over v squared, x plus 1 squared. And then all I have to do is just make this look a bit nicer. So x plus 1 times 1 minus 1 times x, and minus 1 times a minus 3, which gives me 4 over x plus 1 squared. And this is, after all that, f dash of x. It's the differentiation, so it's the formula for the slope of this function. So if you wanted to, you could have just gone straight for the quotient rule. You know, you can try that out actually yourselves and just see, do you get the exact same answer? It'll probably be a bit more complicated, but it's exactly the same thing, except, you know, I simplified and then use the quotient rule. Your other option is don't bother simplifying. So use the quotient rule off back up here, because you still have something over something. So that this will be u, this will be v, but obviously you're going to get an awful lot more complicated algebra, and that you'll have to simplify it down, because every fraction in your exam has to be in its simplest form, and it doesn't matter if it's, you know, normal fraction or an algebraic fraction. Everything has to be in its simplest form.